Alright, in working this particular problem to find the average atomic mass, remember that you have to take the decimal. Oh, got to get my pen. You have to take the decimal percent. Alright, to get the decimal percent, you take the percentage divided by 100. The percent, the first percent is 78.99. So 78.99 divided by 100 is equal to 0.7899. Multiply that times the mass, and that's 23.9850, and get an answer. So we do the decimal percent times the mass. Now the mass is in AMUs, so we need to say AMUs here. AMU equals, alright, take out your calculator, 0.7899 times 23.9850 equals 1818.95, because we have to round up. And we need 4 significant figures. There's 4 significant figures here, so I need 4 significant figures in my answer unless I'm told otherwise. Alright, then I have 10%. This 10%, 10 divided by 100 is 0.1000 times 24.9858 AMU equal. This is also AMU. Alright, so we've got 2.49. Oh, sorry, looked at it wrong. Undo. Yeah, 2 point, I was looking at it right, 9858. Then it says the rest. Well, the mass of the rest is 25.9826 AMU equals, and I forgot again, AMU. Alright, now what is the rest? Anytime you have percentages, the total percent equals 100. So I have 78.99 plus 10 for a total of 88.99%. Now I have to, the total percent is 100, so 100 minus 88.99 is going to be 88.99. Alright, it's going to be 11.01. So 11.01 is my percentage. Divide that by 100, so I get where'd my thing go? I get 0.1101 times 525.9826. And you're going to get 2 .8607. Need 4 significant figures, so that will be enough to add. Alright, now we're going to add those numbers. 18.95 plus 2.49858 plus 2.8607, enter, and it equals 24.30928. Round off to 3 significant figures, so my answer is 24.31 AMU. So AMUs. I can't get that one in back there, but alright, so let's start over. Let's clear the board. Start one more time. Alright, you have to take the decimal percent. So when you're working these, we're going to say decimal percent. That is equal, that would be, you get that by taking the percent divided by 100. Alright, the other thing, the total percent has to equal 100. So if you're given 2 of them and it doesn't tell you the third one, because I have 3 masses, look, 1, 2, 3 masses. So I have to have 3 percentages, and I only have 2 percentages, here and here. So that means I've got to figure out the other percentage. So to find the other percentage, it's 100 minus 78.99 minus 10.00 in your calculator, and you come out with 11.01. So this percentage is 11.01. Now let's do the decimal percentage. We're going to say, I'm going to do it here where I got a little more room. Decimal percent times the mass in AMUs. Now if I write AMU up here, I don't have to write it all the way down. So that's a good thing. If you'll write it up here, you won't have to write AMU after every number. So the decimal percent of 78.99 is 0.7899 times 23.9850 equals, let's see if I can find it again without having to calculate it, but I can't. So it'll be 0.7899 times 23.985. Enter. And the answer is 18.95 AMUs. Then our other decimal percent is 0.1000 times 24.9858, and that's going to equal to 4 significant figures, 2.498, and I can't get it over there. So let me see if I can select this. Nope, it's not going to let me select it. So let me undo or erase. That'd be even better. I will erase this and move it over just a tad, so I'll have enough room to write. So this one was 18.95 and this next one was 2.498. I still can't get my 8 in there. 9, 8. There we go. Alright, and that leaves the 11.01%. So 0.1101 times 25.9826 equals, so 0.1101 times 25.9826 equals 2.861. Now add those numbers up and you're going to get this answer to 4 significant figures. Alright? So let's erase. And now to do the problems from your book. So we'll look at your problems from the book. We're looking at oxygen first, but we're going to say the percent. This time I'm going to do things just a wee bit different, not enough to mess you up, but I'm going to put percent. Then I'm going to put decimal percent. Then I'm going to put mass in AMUs. Oop, left off my U. And then I'm going to put equals, and this will be in AMUs. Alright, so let's start off with the first percent for oxygen is 99.762. Now, we're going to take and get the decimal percent. When I divide by 100, I'm going to move my decimal 2 places. So that's 0.99762. And I'm doing a times here. So times the mass, which is 15.994915. Now, I'm not going to carry it all the way out, and because I'm not carrying it all the way out, I may end up with a slightly different answer than what's in the book, but it will be close enough. So I'm going to say 15. When I multiply those two numbers, I get 15.95684. Okay. Then I go back and look at the second percentage, and the second percentage is a little bitty percentage. So it's 0.03. Whoop, what happened? Ooh, must have done something bad wrong there. Alright, 0.038. Divide by 100. When you divide by 100, move the decimal 2 places to the left, and I get 0.0038. I left off a 0. I'm having a little trouble with my apparatus here, so I'm going to back all the way up and make those zeros a little better. So I'm going to get 0.0038 times the mass in the book. The mass in the book is 16.999131. And when I do that multiplication, I get 0.0064597. Now the next percentage for oxygen is 0.200. divide by 100, move my decimal 2 places. It does not matter that these are little bitty numbers. That's part of it. So don't be afraid to have a little bitty number. And so that would be 0.00200 times the mass given is 17.999160. Alright, come on, thingy. 60. And that when I multiply those two numbers, I get 0.035998. What's the last step? Add them up. So take out your calculator and you would add up these numbers. And when you add them up, you're going to get something in the range of 15.99 to 4 significant, 15.999, I believe, to 5 significant figures. You'll be told how many significant figures I want you to have on the test. So we're not going to worry about the number of significant figures too much on this particular type of problem. On this whole test, there's not too much other than if I say do 6, I want 6. That's all you have to remember. Now the next thing I'm going to do is copper. So this was oxygen. And this is copper. Alright, when I look at copper, the percentage for copper that's given is 69.17. Divide that by 100, that means move your decimal to here, and you get 0.6917 times the mass is 62.929,599 equals. And that's when I multiply those two numbers, I'm going to get 43.5284. The next percentage that's given is 30.83. When I move my decimal 2 places to the left, I get 0.3083 times the mass, 64.927793 equals, when I multiply that, I get 20.0172. Add that up, and we're going to get 63.54, and I don't think this is going to be a 6, so we'll say 5.5. It will round off to be a 5.5, I believe. Alright, the last one was uranium. Alright, on uranium, the first percentage is the T90 bitsy one. It's 0.005. That's a little bitty percent, but it still counts in your average. So we have to divide by 100. Move your decimal to the left 2 places. We've got a little bitty number, 0.00005. And then we multiply that times a big number, 234.040947. And when we multiply that out, we get a pretty small number, 0.00, excuse me, not 0.00, looked at it wrong, 0.01170. The next percentage on the page is 0.72, help if I could write, 720. Move the decimal to the left 2 places, fill in the empty humps with zeros, so 0.00720 times. The number is 235.0 0.043924 equals 1.6923. The last percentage is a big percentage, 99.275 divided by 100. Move your decimal 2 places. So I have 0.99275 times 238.050784. And that's going to equal 236.3202. Add all that up and you're going to get 238.03. Alright, now my numbers may be a little bit off because when I multiplied these I was having a little trouble seeing my calculator, but this is your process. You do this process over and over. Each one of these percentages I was given with to begin, add up. If I were to add them all up, 99 plus this percent, it's going to add up to be 100. We always add up to be 100%. So 69.17 plus 30.83 adds up to be 100%. So when we work with percentage, the total percentage is going to be 100. So that's why we divide each one of these percentages by 100. So we go ahead and write down the percentage, divide it by 100 and write down your decimal percent, put your times thing in between, and then put your masses down and simply multiply them. And when you get through multiplying, add all this final column. Whatever is in the final column will be added together, and that's your average atomic mass. It's just that simple. Alright, so we're going to talk about the homework and the next thing. So I'm going to erase this. Alright, your homework. Homework is, gotta get my point. Alright, so let's start with our homework assignment. I'm going to go ahead and give you your entire assignment, so write this down. The homework assignment is on page 90, number 19, 20, 23, 24, 28. Alright, so let's learn how to do first of all, number 19 and 20 are like today. So this is today homework. This is the same thing. It's got percentages and all the masses. Now these three are new. To work these three, we're going to need to have an equality that we're going to use. So we're going to use 1 mole equals 6.02 times 10 to the 23rd atoms, and that equals the GAM. G stands for gram, A stands for atomic, and M stands for mass. So, the GAM comes from the periodic table, and it is the yellow numbers. Alright, so GAM, gram atomic mass. Look on the periodic table, find the yellow numbers. Alright, so I got to open my book so I can see the numbers. So I'm going to make up some problems here of each type that you can have. The first one, how many moles in 72.3 grams of copper? Okay, so what are you looking for? X moles. What do you know? 72.3 grams copper. Yes, you have to write copper. It's going to seem redundant right now, and it is redundant right now, but later it will be important that you're in the habit of writing grams of copper. Trust me, you will want that. Now, go back up to your original. Let me get a different color here so I can make a note. Go back up to your original equality, which is right there. What do I need to get rid of? Which one of these do I need to get rid of? I need to get rid of grams. Which one of these three equalities has a G in it? Well, there it is, right there. Gram atomic mass. Where do I find the gram atomic mass? On the periodic table. We're going to round off, always round this off to the nearest hundredth of a gram. So when I look up copper on the periodic table, I see 63.546. Round that off to the nearest hundredth. 63.55 grams. Now, where am I trying to get to? I'm not trying to get to atoms. That's not what I'm looking for. I'm looking for mole. What is the number written by mole? This should be copper. What is the number written by mole? 1. So when I use this yellow number off the periodic table, I am always, always, always going to put a 1 above it. 1 mole copper. Now, this is factor label. Right back to where we started, but these are fairly simple factor label. What cancels? Grams of copper cancel. And when I do my arithmetic with my calculator, I got 72.3 divided by 63.55, and my answer is going to be 1.13768 moles Cu. How many significant figures do I need? I have 3 here, and I have 4 here, and we don't count ones. That's 1 mole to exactly 4 significant figures. So my answer should have 3 significant figures, 1.14 moles of Cu. That's my complete answer, and I expect to see a complete answer. Alright, so let's work another one. In this little bit of room I have here, I'll change colors to something else so that it's a little bit, so we can differentiate between them. So now I'm going to say, how many grams, another one of those zaps that got in the way there, grams of oxygen are in 5.21 moles. Okay? Again, What are you looking for? First thing you always identify. What am I looking for? I'm looking for grams. X grams equal. What do I know? It's in the problem. 5.21 moles of oxygen. So we just put an O for oxygen because that's the symbol for oxygen as far as we're concerned right now. It's really not, but we'll get there at a later date. Alright? Now, what do I need to get rid of? Moles. Look back up here. This is our only equality. This is the only factor we have to worry about. And there are 3 parts to the factor, so I have to pick 2 of them. Which one can cancel moles? Which one can cancel moles? Everybody think about it. 1 mole. 1 mole of what? Oxygen. And where am I trying to get to? I'm trying to get to grams. Which one of these 3 has grams in it? There it is. And where do I find the GAM? I look on the periodic table at the yellow number, and I round off to the nearest hundredth. So that would be 16.00 grams of O equal. Now in this case I'm going to say 5.21 times 16. And my answer is going to be 83.84 grams of O. How many significant figures do I need? I have how many here? 3. How many do I have here? 4. So my answer should have 3. 83.8 grams of oxygen. Okay? I'll try to get my eraser here and erase this, because I'm going to go back and do another type of problem, because we haven't used that good old number 6.02 times 10 to the 23rd. Alright, so I'm going to erase this top one, leave the bottom one there in case you need a little more copying time, and I'm going to work another problem. Alright, another problem. How many atoms in 4.31 moles of, let's say nitrogen? Alright, what am I looking for? I'm looking for atoms. So X atoms, nitrogen. The symbol for nitrogen is an N. Equals, what do I know? 4.31 moles nitrogen. Now look at my equality, my factor that I have up here. What do I need to get rid of? Moles. What's the number that goes with moles? 1. 1 mole nitrogen. Now which one of the numbers is going to give me atoms? 6.02 times 10 to the 23rd atoms. Nitrogen. And ATM is an abbreviation for atoms. Alright, take out your calculator. Remember, when you put in this number, it's going to be 4.31 times 6.02 E23. Oh, this thing is giving me grief tonight. 23. So 4.31 times 6.02, second comma on my calculator, 23. And I'm going to get an answer of, to 3 significant figures, 2.59 times 10 to the 24th. Go back. 10 to the 24th. I can't get my 24th in there. Alright, so I'll write it down again. 2.59 times 10 to the 24th what? Atoms, nitrogen. Alright, now I'm going to erase the bottom one. While you have an opportunity to be looking at that, I'll be erasing the bottom one and putting another kind of problem up here. You will have an example of every type of problem that I can think of when I get through here. Alright. This time we're going to say how many moles are in 5.36 times 10 to the 22nd atoms of fluorine, F. Okay? What are we looking for? Moles. X moles of F. Notice every time I put down the element, and you have to too, I don't do it because I want to, I do it because I think it's what you need to do to be successful in the future. So follow my lead and do as I say. Alright, so we've got what we know is 5.36 times 10 to the 22nd atoms of fluorine. So what are we trying to get rid of? Atoms. So what number goes with atoms in our equal thing up here? 6.02 times 10 to the 23rd atoms of fluorine. I think put a nitrogen again. And what number goes with moles? 1. 1 mole fluorine equal. Calculation. 5.36 E22 divided by 6.02 E23. If you come out with some number like 10 to the 49th, you have messed up. There are no numbers that you will ever get that are 10 to the 49th. You put it in your calculator wrong if you get that number. So go back and put it in your calculator correctly. So we're going to put in 5.36 E22 divided by 6.02 E23. And our number is a little number, 0.0. How many significant figures do we need? That's right, 3. 8, 9, 0. Because the next number by the 0 is a 3, so that 0 stays there. And what's the unit? Mole. Mole of what? F. Alright. While you're looking at that one, I'm going back up here and I'm going to erase the previous problem, this one. So you can look at that one while I'm doing this. Alright. I'll have to erase part of that up there because I wrote in it. Alright. Now the only type I have not shown you, there are 6 different ways that you can arrange this, is this one. How many, that's many, grams of zinc are in 9.76 times 10 to the 24th atoms of zinc. Alright, so I am looking for X grams zinc equal 9.76 times 10 to the 24th atoms of zinc. What am I trying to get rid of? Atoms. What number goes with atoms from my equality that's written up here? 6.02 times 10 to the 23rd atoms. What am I trying to find? Whoops. Atoms, zinc. What am I trying to find? I'm trying to find grams. Where do I find grams? GAM. Where is it located? Periodic table, yellow number. Zinc is 65. Look it up with me. 65.41 grams zinc. Calculation. 9.76 E24 times 65.41 divided by 6.02 E23. Again, if you get a big exponent, if your exponent's much bigger than 23, 24, 25, you have put it in your calculator wrong. So 9.76 E24 times 65.41 divided by 6.02 E23 equals, wow, I got the wrong number. I'm hitting the wrong button. I'll try again. Alright, so we've got 9.76 second comma on my calculator 24 times 65.41 divided by 6.02 second comma 23, and we're going to get the answer is going to be 1060. How many significant figures do I need? I've got 3, I've got 4, and I've got 3. So 3 significant figures. How many significant figures do I have? The unit, what happens to the atoms? They cancel. So the unit is grams of zinc. Alright. I'm going to erase the last one on the bottom. I'll leave that one up there in case you need to write and you're catching up with me. I know I'm going a little bit fast. And you can get this replayed if Ms. Harrington is willing. She can replay it for you if you need it. Alright, the last one is how many atoms are in 53.7 grams of sodium, Na. What are you looking for? X atoms, sodium, equal, what do you know? 53.7 grams sodium. Look at your equality. What do you know from the equality? You know the GAM. Look on the periodic table. Find it. Okay. 22. 22.99 grams sodium. That has to go on the bottom so I can cancel my grams of sodium. On the top, I'm looking for atoms. The number that goes with atoms is 6.02 times 10 to the 23rd atoms of Na. So calculator, you're going to say 53.7 times 6.02 E23 divided by 22.99. So 53.7 times 6.02 E23 divided by 22.99 equals 1. And if you're not careful on this, you'll leave something out. How many significant figures are we going to get? Let's change colors if we can. It'll let me change colors. There we go. We have 3, we have 3, and we have 4. So our answer should have 3 significant figures. So 1.41. Now, if you don't look all the way at the end of your calculator, you're going to miss this times 10 to the 24th. There's a lot of difference between 1.14 and 1.41 and 1.41 times 10 to the 24th. Atoms. When you have atoms, you're going to have a pretty big number every time. Na. Atoms of Na. Now, you are going to do 2 problems like the homework for today. Alright, 2 problems, 19 and 20. But I want you to also work at least 1 problem from each one of these if you can before you leave class today. That way you can get some help from your study buddies at your table if you need them. So work at least 1 out of each one of these if you have time today, and make sure that you have your homework on Tuesday, unless I might check it. And if I check it and you don't have it, I'm not going to be a happy camper, and you won't be either. Okay, so y'all get busy and get to work on that homework. Alright, I'm fixing to stop this. Good luck.